You know. Anyway, guys, it's 5 o'clock. We're gonna start up space news. But yeah, we'll keep working on the cargo terminal next week. Tomorrow we got Minecraft, so I've been basically playing cities in Minecraft. So if you like how I build cities and how I kind of roll with this, we're doing a community project in Minecraft that we're gonna play tomorrow. But I'm gonna start space news now. We used to have bumper stickers on the Cape that say "Stop the outflow pipe." Is it the outflow pipe that they shut down in the 90s? No, it was part of the Big Dig, dude. It was part of the Big Dig. Yeah, freaking. I gotta save the FAA stuff. Oh, nope, that was the selection statement. We need that. Hey, Shirley. I just finished working on the airport today, yeah. Mm-hmm. Okay. Alright, let me, switch the title over to Space News. And I hope you guys enjoyed learning about airports today. I actually learned a lot. And I will be right back. I am going to take a quick break. I'm going to go grab another... I love a Coke. I'm going to grab another one. Wait, ginger ale. We don't have Coke, remember? And I will find you guys something to... Actually, I'm just going to take a quick break. We should still have the Cosmo, or the CSG-2 launch. That's still scheduled for 6/11. No Sam Adams? That's for later. Here's that video from yesterday. Thank you. Oh, I don't think we should watch the whole thing, dude. But yeah, it's... Oh, that's cool. I'm gonna save that for off news. Thick clouds today, goalie. All right. And believe me, when I was talking with Shuttle, if you guys are still here, if the people are still here, you guys, I saw people saying more flight simulator. We'll see what we got. Okay. Give me 1 second. I'm looking at something. Okay. Just wanted to see that. All right. Let me find a video here. Oh, sweet. I got a jam handy video for you guys. Here, check this out. I will be back momentarily, okay?
Steering a heavy vehicle by manual effort only emphasize the need for a steering assist. This has been accomplished by adding a hydraulic system to the cam and lever steering mechanism. In this film, we will discuss the principles of operation of the hydraulic steering system. This vehicle uses a cam and lever steering mechanism consisting of the following components: a steering shaft and cam, a pitman arm lever, a pitman arm shaft and pitman arm, a drag link, and a tie rod. To obtain the assist, a hydraulic system has been added to the cam and lever mechanism. The hydraulic steering system is made up of 5 major components: the reservoir, pump, relief valve, control valve, and power cylinder. These components operate on the principle of pressure differential. Pressure differential is illustrated by this section of pipe. In the pipe is a movable block. The arrows on either side of the block represent equalized pressure. As pressure on one side of the block is increased, a pressure imbalance or differential is created in the pipe, moving the block in the direction of the lower pressure. The moment the pressure on the opposite side of the block is increased to equalize the pushing force, the motion of the block is stopped. In like manner, as the fluid pressure is increased on one side of the piston will be moved by pressure differential, aiding in steering the front wheels through the steering linkage. To aid in illustrating the internal function of the hydraulic system, a schematic diagram will be used. The steering linkage from the pitman arm lever to the front wheels will not be shown. Let us view the 5 major components of the hydraulic system as they operate progressively to deliver the steering assist. The reservoir supplies fluid. The pump, driven by the engine, delivers the fluid under pressure to the relief valve and control valve. The control valve, actuated by the steering shaft, directs the fluid to the power cylinder. The power cylinder converts hydraulic pressure into mechanical force by means of a piston. The control valve is the heart of the hydraulic steering system. The control valve has a spool which directs and controls the flow of fluid to the power cylinder. With the fluid removed, let us look at the internal construction of the control valve. The spool has lands which control the flow of fluid through the passageways to the power cylinder. The fluid enters the control valve through the inlet port and flows around the spool in channels leading to the power cylinder. After the cylinder has been filled, all fluid then flows to the reservoir. In order for the hydraulic steering assist to operate, it is not only necessary for the cam to rotate, but it also must be able to move up and down. A spline connection makes this possible. Were it not for the splines, the steering wheel itself would move up and down. The cam is held in center or neutral position by a spring at each end, supported by the steering gear housing. The pitman arm lever, which actuates the pitman arm, has one end fastened to the piston rod, the other in mesh with a groove in the steering cam. When the steering shaft is turned, it requires a greater effort to turn the pitman arm shaft and lever than to compress the springs at either end of the cam. This is so because the pitman arm shaft and lever are connected to the front wheels. This action causes a cam spring to be compressed, allowing the cam to move up or down, depending on the direction that the steering wheel is turned. This up and down movement of the steering cam actuates the control valve through the valve lever linkage. Full pressure of the hydraulic system is applied with only a few thousandths of an inch of control valve travel. In neutral position, all fluid flowing into the valve from the pump is returned to the reservoir through channels in the upper part of the valve housing, and no steering assist is being delivered. As the steering wheel is turned, the up or down movement of the cam actuates the control valve lever, shifting the position of the valve spool. The spool lands corresponding to ports on the valve housing direct the flow of fluid from the pump to the power cylinder. This flow of fluid causes an immediate pressure increase on one side of the piston in the power cylinder. At the same time, fluid from the other side of the piston is displaced by pressure differential and forced up and around the unrestricted passageway in the control valve to the outlet port leading back to the reservoir. The pressure differential in the power cylinder moves the piston and piston rod, thus applying a mechanical force to the pitman arm shaft lever, turning the wheels in the desired direction. When the piston reaches the end of travel in the power cylinder, the pump continues to deliver fluid, causing an increase in operating pressure. The relief valve provides an escape for this excess pressure back to the reservoir. After completing a turn, the driver releases tension on the steering wheel, and the steering system is returned to straight-ahead position by the steering geometry of the front wheels, allowing the hydraulic system to return to the neutral position. To steer in the opposite direction, the cam actuates the control valve lever the other way, and pressure is now directed to the opposite side of the power cylinder piston. When the front wheels are held in a constant turn, the cam will not be rotated. The pitman arm shaft lever is held stationary toward one end of the steering cam by the increased pressure on one side of the piston. The tendency of the steering geometry to return the wheels to the straight-ahead position is overcome by the driver, who maintains a constant force on the steering wheel in the direction of the turn. These two opposing forces cause the steering cam to partially compress the upper cam spring. This also moves the control valve linkage and positions a valve spool where fluid pressure will equalize the force exerted by the steering geometry acting on the piston rod. The front wheels can then be held in any desired degree of turn. On return to neutral, all fluid from the pump is directed back to the reservoir. The pressure is lowered throughout the hydraulic system, and the piston and piston rod do not function. One of the steering problems of the heavy vehicle with cam and lever steering is road shock. Road shock causes kickback of the steering wheel and makes control of the vehicle difficult. On the other hand, heavy military vehicles equipped with hydraulic steering resist road shock through a reverse action in the power cylinder. When one of the front wheels is subjected to road shock, the shock is transmitted through the steering linkage to the pitman arm and the pitman arm shaft lever. The pitman arm lever then actuates the cam, causing it to move up or down depending on which wheel receives the shock. The movement of the cam actuates a control valve, which in turn directs increased pressure to one side of the piston. This increased pressure will be equal to the shock received by the front wheel, causing the front wheels to remain in a straight-ahead position. Now let us review the operation of the hydraulic steering system. The reservoir supplies fluid. The pump, driven by the engine, delivers the fluid under pressure through the relief valve to the control valve. The relief valve provides an escape for excess pressure back to the reservoir. The control valve directs fluid to the power cylinder. The power cylinder converts hydraulic pressure into mechanical force, which in turn actuates the pitman arm shaft and lever and the pitman arm, turning the front wheels of the vehicle through the steering linkage. In order for the hydraulic assist mechanism to operate, the steering cam must be able to move up or down to actuate the control valve. A spline connection makes this possible. The cam is held in center or neutral position by a spring at either end. The slightest movement of the cam results in a pressure differential in the power cylinder and an applied force on the pitman arm shaft and lever and the pitman arm. The hydraulic steering system resists shock and kickback through a reverse action in the power cylinder. With military vehicles getting larger and heavier to meet the demands of modern warfare, the hydraulic system is becoming increasingly important as a power assist in steering the vehicles.
All right, dudes, I'm back. Sorry, you know what I did? I couldn't find what I was looking for about the discharge pipe, that extra pipe at the Big Dig. So I called my uncle. He worked on it, turns out, and yeah, he told me what it does. If you guys are interested, Mission Control audio is live. Excellent. I'll show you a discharge pipe. No, I didn't hear that sub alert. Did you guys hear that sub alert? Hold on. So, on the other side of space, or on the front side of Space News, or the front side of the break, we were trying to figure out. I was like, "There's another pipe out here. There's another thing out here. It's actually from this. It's from the sewage treatment plant, and it's a discharge pipe, and it goes a couple miles out into the harbor. And what the discharge pipe does is it takes the sewage that's been treated and pumps it out into the ocean. Yeah, it's a 14-foot pipe that's 35 feet down, and then it goes straight out like 3 miles this way. That's a long way, which is actually pretty cool. Still in use? Yeah, of course it was in use. Of course it's in use. Yeah, my freaking uncle's a general contractor. He worked on it. He worked on all this. He was telling me, I was on the phone with him, he was telling me when they brought these big eggs in here, right? They brought them in on a barge, and they were sideways, and they used a huge crawler crane to turn them upright and place them, which is actually pretty cool. Yeah. Freaking, it's a poop pipe, so you guys weren't wrong when you said it's a discharge pipe. I don't know exactly where it is. I'm not sure if we could find it. My money's on it being right there and going under here. That's my guess. Because that looks like that's where it would go. But yeah, this is Deer Island. There's a huge water treatment plant out here. Weather is red at the Cape due to thick clouds. SpaceX is still proceeding. Oh, well, all right. Yeah, it's the Deer Island waste processing. So yeah, there you go for people that were wondering about that. Anyway, so we do have the CSG-2 mission happening soon. The probability of violation is a little bit high. What'd you guys think about the hydraulic steering video? Pretty cool, huh? It's power steering, man. Most power steering is rack and pin nowadays, but the pump part is still the same. So it's an analyse for Boston. It is in Gillette Stadium. Gillette Stadium isn't in Boston, Admana. It's not in Boston. It's in Foxborough. Heathen. I sent you a PM on here. Can you read it sometime? I saw the ship starting thing, Dethrone, on my break. Pretty cool. Most power steering is electric now. On Mercedes-Benz, Sawyer, is the end of that sentence. Have you ever seen the Roscosmos Station proposal? I have. I sent you a PM on here. Can you read it sometime? No, I don't know how to read, Dethrone. Sorry. I don't know how to read. I'm sorry. I forgot how to. I don't know how to read. I saw you teaching her how to read. You never taught me how to read, which is why I still don't know how to read. Anyway. So, let's see. I have some Space News stuff here. Let me just transfer some links over and we'll get into it. We have a source selection statement. That's pretty cool. About commercial low Earth orbit destinations. We have a European company called PLD Space that's working on partially reusable rockets. I had no idea existed until about a couple hours ago, which is pretty neat. That's pretty cool. Have you heard? Have you heard the GME T50 Cosworth V12? Or GMA T50? No, I haven't. I think I'm a minute or two behind where you just responded on mine. Yeah. I saw the video. It's really cool. Yeah, the ship starting up. That's really neat. I dig it, my dude. Let me... I'm going to get the mission control audio up, first of all. See if the mission control audio says anything. Final weather call is set for T-minus 2 minutes. Alright, well that means they're going to get the cast going. Here. That should be happening in the next 15 minutes. Let's see. I'll get a little bit of space news done now. I wanted to see that source selection statement first. Let's see. All right, let's check this out. Actually, you know what? We'll get into some other news first, real quick. Here. Is the sub notifier on? Alleviate. I didn't hear your sub pop through, but I did. Oh, I did see it. Here, let's try to.
Discovery, go at throttle up.
It works now. 26 months and EJ's still my #1 most watched streamer on here. What a way to spend it with a Falcon 9 launch. Let's go. Fingers crossed, no scrub. Well, you said it now, so it's probably gonna get scrubbed. You said something, so probably gonna get scrubbed. Let's see. So Relativity's Flashback Friday to completing our first flight Aeon 1 engine. Special thanks to our stellar engine manufacturing and engineering teams for persevering to hit this exciting milestone. So yeah, there's a 3D printed engine right there. Like 90% of the components on that thing are 3D printed, which is really... That's really something, to be honest. Wait a minute. I like Relativity more now. EJ, you good for the Nor'easter coming up? Yeah. No. No. Not really. I don't want snow. I hate snow so much. That's cool. I like Relativity more now. So, let's see. So there's coming from Relativity. Speaking of that, here, you know. NASA, we're studying how snowstorms form by flying planes through them. Oh, that's coming. That's a previous snowfall, but there is a big snowstorm, big one. Yeah, like blizzard conditions, big, coming towards us. Where the heck is it? Oh, frick. Okay. Yeah, that's not good. All right. Yeah. Oh, there it is. Yep. Nope. Here. Yep. Okay. Yeah. How's the Cape doing? Ooh, that's actually thick clouds. High altitude and low altitude clouds right there. Here, let's see what the Cape looks like. Look at the low clouds. Low clouds are not a big deal. What about the cloud base? Visibility? What about the clouds? Oh, yeah, that might scrub this. Yeah, Connor, we're about to get railed. Go to the grocery store. That's what I did this morning. This morning and yesterday. Yeah. Oh, Nikes. Yeah, that's not good. Oh dear. All this stuff that you guys see a bunch of dots on. Yeah, that's no good. Bye, TP. We have plenty of toilet paper. Don't worry. I forgot the milk and bread. I forgot the milk and bread. I forgot the milk and bread. Oh. Yeah, that's bad. Okay. So check this out. So Windy has snow accumulation in the next 3 days. And frick. Oh no. Oh, we're gonna get railed. That's not fun. So the blue is lesser snow. I'm gonna get more snow than you. Damn it! So okay, what about damn it. Oh, that's like the 3-foot indicator. See how it's like greenish right here? Oh, that's where I am, where my mouse cursor is. Like, oh no, I'm just outside. Oh, this is gonna suck. Oh my god. Oh. I hate snow. I hate the snow. I hate the snow. I hate the rain and I hate the sleet. But most of all, I hate the snow. Barnstable. Yeah, you're not as bad, dude. You're only gonna get 20. What is that? 20 inches. So you're only gonna get 1.5 feet, dude. I'm gonna be sitting over here with 3 feet of snow. 3 feet of snow, for the people that don't know, is 90 centimeters of snow. 90. That's almost a meter of snow. Why? Why? All right. Well, that's good. Great. Grand. Wonderful. My favorite part of snow is watching it from San Francisco. I don't get earthquakes here. You lose. No yelling on the bus. Far Night, I saw your ping in Discord, but I was live, so I don't generally like pop over there. I know you were asking for like questions. You meant James T. Bajian or James T. Kirk? No, James P. Bajian. I'm not too familiar with that name, Far Night, to be honest with you. Man, my daughter wants to go sledding so bad. I wish we'd get that much. Is SpaceX still going up? I have the mission control loop on here, but yeah, I don't know, man. A lot of clouds. We just had an earthquake in Connecticut, a small one, but it happens. An astronaut on STS-29 and STS-40. That's cool, Far Night. Awesome. I didn't get your... I saw the tag in Discord. Here, let me read it. I mean, you threw it in general. Let me see. Yeah. What did you ask? What'd you ask him? You were meeting him, but that was a... What do you mean we don't get earthquakes up in Massachusetts? All right, here we go. Here we go, guys. Here we go. So, you know, we get stuff like the Loma Prieta earthquake, right? That happens up here. So, yeah. And it's never ever snowed in San Francisco ever in the history of mankind, right? Yep. All right. So here, now is one of those times where being technical is making you look stupid. So don't do that because we're kidding. This is a joke. Don't need to take it so literally. I see people doing that in chat. Now's not the time to do that. Now's not the time to do that. When we're discussing, like, flow dynamics of rocket engines, that's the time to be technical. Now's not the time to be technical because jokes. See what I'm saying? Anyway. Let's see. Far Night. Heck yeah, it was awesome. We talked for space like 30 minutes. It was really cool. Told the story about his computer going nuts and telling him the shuttle was going to explode. Yeah. Ooh, not a good day to tell a story like that. I mean, if you guys look at the date, but whatever. It's sunny and 55 minutes. Yeah. All right. Yeah, I was like, yeah, good point. I'd be like, no, don't tell that story today of all days, man. What's wrong with you? So, for the people that don't know, just on a side note, it's January 28th. It's the, well, what is it now? 2016 was 30 years. And so it's 36 years ago. Yeah, the Challenger explosion happened today. STS-51L O-rings and wind shear equals bad. Yeah, I still won't ever show that on stream. I can't do it. I can't watch it. I can't watch it. It pisses me off so much, man. I can't watch it. Freaking can't do that. It's yeah, it's tough to watch. But hey, you know, it happens. Yeah, and Wednesday is going to be 19 years for STS-107. How about we just don't launch anything in January or February? How about we just don't do that? Yeah, teacher in space. Yeah, Krista McAuliffe. Krista McAuliffe's from Framingham, Massachusetts. Ketrick, she was a teacher in New Hampshire. Yeah. Yeah, she's from Framingham. That's like 2 towns over from me. Yeah. I can't do it, man. I can't watch it. I've tried. I've tried to watch Challenger. I can't do it. Right when I see, every time, I get it. It's just a video. Just watch it. No, but it sucks. Every time I see the shuttle at about 70 seconds start doing this, I just shut it off. I can't do it, and I won't ever show it on stream. I can't. I'm not doing that. You know, it's tough to watch, man. But anyway, well, 36 years. Don't forget, I was in Arlington, Texas at American Airlines training facility. They canceled all the classes that day. Jeez. Falcon Heavy demo was in February and it was glorious. Yeah. Mm-hmm. Can Falcon launch in 30 and 20 degree weather? I don't know. Was that accident avoidable? Very avoidable. Yeah, Liam. Challenger in terms of how avoidable it is was literally blowing a stop sign. Like, that's the equivalent of the stupidity involved there. Oh, there's a stop sign. It says stop. I'm just going to step on the gas and go through the intersection and get T-boned. But in this case, you get T-boned by physics. It's literally blowing a stop sign. Yeah, you could do it. Yeah, you might be fine. But why would you risk it? No, Kyron, no, we good. Guys, Challenger was ignoring physics. That's what normalization of deviance is about. And that's why it's so important to do all these tests. A lot of people harp on NASA with SLS and doing all these tests. Why are you doing all these tests? Why? Just launch the thing. No, shut up. How about we do all the tests and we make sure we understand what we made correctly before we do something dumb like that? It jars on me every time, dude. That's a documented phenomenon in spaceflight called go fever. That's not good. Don't get antsy. Don't get antsy about it. Not a good idea. That's what happened with Challenger. They got pissed off that the shuttle was so far behind schedule and they said launch it anyway and killed 7 people. It's an engineering ethics class. Yeah, that's true. So if you... It has to do with the O-rings on the SRBs. Everybody knows about that. But there's there's a thing with the Challenger program with the that mission. There's a thing, well, not with the mission. It's hard to explain. All right, here, let me start from the beginning. So everybody knows about the O-rings with Challenger, right? And the O-ring failed. The O-ring fails. You get, it's called SRB blow-by, all right? Basically, because the SRB is a bunch of pipes that are basically bolted together, right? And then it has a nozzle at the bottom, right? You need to create a seal between the segments, right? And they were using a 2 O-ring design. They had 2 O-rings in there, 2 fault redundant, pretty straightforward stuff. So everybody focuses on these O-rings, okay? And this, once again, this is the real important thing. Everyone makes, it's not a mistake, but saying it's just about the O-rings, right, is not the entire part of the situation. That's not teaching the entire lesson that Challenger, well, if I'm going to try to take something tangible and good from that, this is the lessons learned, right? The O-rings would malfunction in the cold. They get cold. The rubber seals in the O-rings, because O-rings are made out of rubber, they get too cold, they crack, they become brittle. So when you turn the SRB on, they basically fail. They don't work. So you get a phenomenon called SRB blow-by, right? Now, SRB blow-by is when some of the SRB's exhaust gases go out the side of the booster instead of out the bottom. You really do not want that. That's a really bad thing. Now, here's the thing. The SRB blow-by only happens for a second. It only happens for a split second. And the phenomenon that they were encountering up until Challenger is that it was fine. It was okay. The SRB gases are so ridiculously hot. What would happen is if the O-rings failed and some SRB gas snuck through, right? It was, the gases from the SRB are so hot they would actually end up hot welding the segments together. And then when they went and fished it out, they would have to cut the segments apart, and everything was fine, right? Not really, but so there's your normalization of deviance right there. I want the SRB O-rings to seal, and I want them to seal every time. And I launched the shuttle with people aboard, and they didn't seal. And somebody at NASA thought that was just totally okay. That was a totally okay thing to do. And just kind of go, yeah, just keep launching it. It's fine. Now, here's the thing. In that regard, they were working just fine. The SRBs were working just fine. They would seal. So you'd launch into space. And they had SRB O-ring failure on multiple shuttle flights before this happened. They knew launching them in the cold was bad. Here's the part that no one ever talks about, and I don't understand why. Challenger, January 28, 1986, the STS-51L mission. They launched it with not one constraint, not one launch constraint violation, but 2. It was too cold to launch the shuttle. They knew about that, but they knew the cold would just seal the SRB O-rings and kind of go from there. What nobody ever talks about is that there were 2 launch constraint violations. There was there was an upper wind violation, right? It was too windy up there. Now, what does that mean? What do you mean it's too windy up there? There's lower level winds, the mid-level and upper level winds, okay? Upper level winds in meteorology are really, really dangerous. They're really dangerous for rockets. They introduce insane shearing force to a rocket. Rockets are really designed, they're basically a pipe, right? And they're designed to have forces, aerodynamic, gravitational, whatever, basically go up and down on the long axis of the vehicle. The forces are supposed to be applied like that. Force being applied to the side doesn't really work too well for a rocket. My analogy for this would be like if you tried to take a skyscraper and make it a bridge. Doesn't work very well, does it? If you took a building and you put it on its side, and you put it between, like, over a river, it's not gonna work. The building will fall into the river. It'll break, or by some miraculous thing, it'll just kind of sit there, right, and maybe be like this. Point is, it won't act as a bridge, and if it does, it's not gonna do it for very long. Rockets are the same way. They're not really designed to have forces applied to the side of them. That's a shearing force. Okay, shearing force in dynamics. It's something. It's a subset of dynamics, which means stuff being applied and then not applied, as opposed to statics. Statics is civil engineering. That's buildings and stuff, right? Stuff that doesn't move. So a shearing force is applied like this. So if the rocket's pointed this way, it does that. That's shearing force. Now, okay, getting back to upper level wind shear. Why is that such a big problem? Well, the pressure is lower up there than it is down here by a very, very, very significant margin. You have exponential fall off the higher you go. So up 70, 80,000 feet, there's not a lot of pressure up there. Because there's not a lot of pressure up there, air can move around a lot faster. Upper level winds, 200, 300, 400 miles an hour, easily. Easily. Very, very, very high speed winds up there. So, there's a wind shear upper level winds violation and a temperature violation for the shuttle, and they launched it anyway. The SRB did exactly what they thought, based off of prior data, did exactly what they thought they would do. The SRB O-ring failed at booster ignition, and just as expected, as previously encountered, it sealed the O-ring, it welded the two segments together, and Challenger took off just fine. No problem. Well, kind of. The thing about that the two segments welded together, well, you haven't tested if that's going to hold up to some wind shear, have you? No. Why? Because the rocket's ultimately doing something you don't want, and you'd be like, yeah, that's cool. No, it's not cool. Don't do that. They figured out 73 seconds later why you don't do that. So, 70 seconds in. So, 3 seconds before the thing pops, right? Challenger gets hit with the highest recorded wind shear on any rocket stack ever from the Cape. It was enough to crack the SRB, the faulty O-rings. It was enough to crack the two segments open like this. And unfortunately, the side that opened was the side that was facing towards the external tank. I don't know about you guys, heating up hydrogen seems to not do very good in the past. When hydrogen gets heated up and it finds a source of ignition, it usually doesn't end well. So, Challenger did not just have one launch constraint violation, it had two, and they still launched it. So, that's an important thing to understand. No one ever talks about that. I don't know why no one ever talks about that. The wind shear is a critical component. It's a critical component to understanding why this happened. Everyone talks about the O-rings, and the O-rings are the root cause, but it's not the actual reason why it failed. They had SRB blow by in the past, and the shuttle made it into space, no problem. If the upper level wind shear on January 28th, 1986 had been a little bit lower, or the upper level wind speed had been 10, 20, 30, 40 miles an hour lower, Challenger makes it into space, no problem. And it comes right back down, and everybody's happy. See what I'm talking about with Challenger? I don't know why no one ever mentions this. I've read the freaking the Rogers Commission multiple times. I haven't read it in a little while. I should probably do it, but SpaceX is live. There was an airliner that reported, it was hit, like I said, hit with the highest wind shear. It's crazy to think that Nelson was on the flight right before Challenger. He trained with them. That's right. So it's important to understand that, guys. It's important to understand that, the lesson learned here is that spaceflight problems and catastrophic failures happen from compounding errors. And NASA learned this that day, and they learned it the very, very, very hard way. You don't just say, it's fine. It'll be okay. It'll be fine. No, you have to make sure all the T's are crossed, all the I's are dotted, and you have to validate and you have to quantify your work. This is one of the reasons why NASA goes slow, even to this day. You do not want that happening again, ever. ever. Look, the thing is that if you really want to talk about this, the thing is that people are going to die in space. If we go further into space, it's inevitable that people will die. Hopefully, it's because of old age. Hopefully, people are going to get hurt. It's going to happen. Like, it's inevitable. You know, we don't go and do stuff like this. You don't go just doing stuff like space flight, you know, and then everything goes honky-dory. It's not, it's dangerous. It's very dangerous, and people will get hurt. But with that being said, there's a difference between, you know, just a freak accident happening like Columbia. Columbia's a freak accident, and I'll talk more about that in a second. And then just being a freaking lemming and hitting the go button and blowing up 7 people for no reason. All right, there's a big difference there. Do you think if Challenger didn't launch, it would still be an inevitable event? Dude, that's the thing about physics, man. Physics doesn't change. It doesn't change. It doesn't change. It really doesn't. As long... If it wasn't windy that day, Challenger flies into space and no one's the wiser. That's it. Do I think it's inevitable? They probably would have ended up launching the shuttle sometime down the road on a windy day. But, yeah, it sucks. I don't know. I think that Challenger, I mean, people use it as an excuse to take money away from NASA, and they still use it as an excuse to take money away from NASA nowadays, which really blows, but that is what it is. What if it was windy but a lot warmer? Well, Seinerd, the fact that you don't have data on what a blown O-ring SRB segment that's welded together from SRB gases, you don't have data on what's gonna cause that. That's a known. That's an unknown unknown. You don't know. This is what I mean about testing. You have to test for every conceivable thing. And the thing about testing rockets is that testing rockets in components, and even SpaceX is like this to an extent. Testing rockets is not about putting it on the test stand and then watching what happens and being like, oh, I learned something new. That's not how rocket testing works, okay? You don't want to learn something new during your tests. I'd say that testing rockets is not like, it's not really scientific in that, like, you're not doing an experiment, right, and you're figuring and jotting down the results. This isn't 7th grade science class, okay? You have to do the math out for what you think is going to happen, build the thing, and then test it, and then make sure that what you test...
Hold for the cloud rule.
Damn it. Clouds. Scrubbed. You have to,
As launch director to Captain Net, we're ending today's launch attempt.
Hang on.
Due to weather rule violation for the thick cloud rule, last report from the weather officer indicated the cloud that was violating the rule was violating by excess of 1,000 feet. Launch control, can you confirm launch auto is ended and launch abort auto is started?
Yeah.
Affirmative, launch abort has started.
Okay, well, I'm shutting that off. That's the CSG2 countdown net. So that's a scrub. My understanding is that they already... Yeah, you didn't let me finish. So, yeah, it probably would have been okay. I mean, but I don't know. You don't know. Maybe we should... That's what I'm trying to tell you. Maybe you should have tested that. But what they never tested was a failed O-ring getting hit by wind shear. Failed SRB O-ring getting hit by wind shear at low pressure. You never would have tested that, and that's the problem. That's the problem. Okay, if you have SRB blow-by, right? And like I said, they were observing that this thing was happening. There were engineers at Morton Thiokol that were like, yeah, the O-rings aren't working correctly, but it's sealing. And you know what they did? They said that, oh, well, if the first and the second O-ring fail, the SRB will seal. it'll weld itself together. And that's, oh, wow, sweet. That's a third redundancy right there. Sweet. So something that we engineered to be 2-fault redundant is now 3-fault redundant. And then they never bothered to test it. They never bothered to put it to do any validation on wind shear forces, dynamic forces, stresses, anything with the broken O-rings. That's... So, Synerd, I don't know. If the O-rings, if it was a little bit warmer and windy, maybe it would have made it. I don't know. I don't think there was data on that. I know that if I'm gonna go out on a limb and say if there were 2 launch constraint violations, why isn't that working? Striker, 50. If there were 2 launch constraint violations and one of them was a wind shear violation, that means it probably wouldn't have made it with sealed O-rings. It was too cold and it was too windy, and they launched it anyway. The too windy part is why it failed. Striker, just hitting share here. Gonna be lurking while I'm doing some emails. Hope you have a good week. You too, buddy. Yeah, I know. I get you. The failure was that they failed to test just how sealed was. Yeah, exactly. It's you don't want to learn something new during testing, and you know where you really don't want to learn something new when there's people involved. So. Little thing on Challenger. That's why I can't watch the footage. I just can't watch it. It just pisses me off. It's so stupid. It's so dumb. Like, oh my God. Well, see, Kyron, with Apollo 1 is a little bit different. Apollo 1, they knew about the shorts. They knew the capsule wiring could short itself out. But, you know, you got to understand the context too. And there is context Challenger. You know, it's easy to point the finger at the people that said, "Oh, launch it." The people at NASA that were under pressure to go ahead with the STS-51L mission, right? They were under huge pressure from their higher ups, to perform. The shuttle program was notoriously behind. Just like SLS is notoriously behind right now. It was the same thing. They were behind by years at that point. But the thing is that they weren't behind by years. This stuff takes time, and it's something you got to understand. You know, when Starliner has valve problems, everybody says, "What a piece of junk." Yeah, because you can do better. No, you can't. This is normal. This stuff happens. Every spacecraft. Sometimes you catch it before it kills someone. And that's going back to Apollo 1, right? They were going really fast because they were under pressure to get it done. Because we choose to go to the moon. So NASA took some liberties with safety. They paid for it, but it paid off, fortunately enough. They knew about the shorts in the capsule. They knew about it. They knew that could happen. And it's funny because Gus Grissom is the reason, Gus Grissom's Mercury flight is the reason why the Block 1 Apollo capsule had an inward opening hatch. The reason why it had an inward opening hatch is because of Liberty Bell 7? The hatch blew prematurely when the capsule splashed down because of a wire short, and the capsule sank. So that had an outward opening hatch. So outward opening hatches are bad now. So they switched to an inward opening hatch because of what they learned from the Mercury mission. Not entirely realizing that the reason why you lost the capsule is because of a wire short. A wire short shorted out. It blew the hatch off, right? It opened up the hatch prematurely, and water started pouring into the capsule, and the capsule sank, and Gus barely got out. This was the Liberty Bell 7 mission, so it was Mercury flight. And then later, they switched the hatch design. They went with an inward opening hatch on Apollo 1, and a wire shorted again, and the Grim Reaper finally came. You know what I mean? You're not recognizing that the wire shorts are the problem, not the hatch. It has nothing to do with the hatch. This is why this stuff is so complicated. Capsules have teething problems. Every spacecraft does. And the thing is, it's better to take your time during the testing, validate as much info as you need, and go from there. That might take years. It does take years. You want more people dying? I don't. Take your time. Get it done. Well, the good news is that NASA man hardware is now the gold standard for wiring. Yeah, and that those rules are painted in blood. That's great. What should NASA have done to the shuttle program after Challenger? I know you're not a fan of how they managed it from then on. Why is this satellite exactly a 24-hour reset, but other satellites change launch time by minutes every scrub? This is a low Earth orbit satellite, goalie. It's a low Earth orbit satellite, so the mechanics pretty much are just 24 hours all the time. The Cosmo... Hold on, I'll answer that question about the shuttle in a second. Cosmosat are... They're made by the Italian Space Agency, and they're Mediterranean basin monitoring satellites. So they're used for search and rescue, monitoring the climate. Yeah, they used them for SNR. They used the Cosmo SkyMed 1 constellation, which is 4 satellites that was launched on Delta 2s back in the day, has been used to like monitor for earthquakes and stuff like that. It's a low Earth orbit satellite constellation, so because it's a LEO satellite constellation, 24-hour scrub is just fine. Just like a Dragonflight or anything else. Anyway, I don't want more people dying, but I also accept it's probably going to happen. Simply because this whole concept of space shuttle is inherently dangerous. Of course, Signer, you probably didn't hear me when I said it, but more people are going to die in space. It's going to happen. There's too many unknowns, and I don't want it to happen. It's probably going to. Let's just make sure it's not because someone's being an idiot, like too much. We don't want something like Challenger happening again. That was just stupid, just dumb. In the end, mistakes were made, but they were mistakes that no one knew were mistakes. Disagree, hard. Challenger, they knew they were making a mistake and did it anyway because they were under pressure to get stuff done. Because the people that set the dates for the shuttle program didn't understand how aerospace engineering works. I would call Challenger, Don, I disagree. I would call Challenger pretty pointless. It was a pretty pointless loss of life. You shouldn't have launched that day. All the signs were there, and they knew the signs were there, and they still did it. Very, very stupid. Just like blowing a stop sign. What are you doing? Yeah, you could blow a stop sign. You could go through a red light. You probably will be fine. Probably. You want to risk it? It's a stop sign. It's there for a reason. It's called Go Fever. Yeah, that's bad. Where you just kind of take some liberties with physics. The thing is that you can't take liberties with physics. The laws don't change, and they'll come back to bite you if you don't know what you're doing. Once again, this is why I'm, like, with SLS, guys, I'm annoyed that it's taking so long, just like everybody else is, and I'm annoyed that the price is high. Well, I mean, one, the price really isn't too high. It's just sticker shock because people don't understand how funding for NASA works. And two, take all the time you need. If it takes an extra 6 months, it takes an extra 6 months. That's just how it is. You know, it's not much you can do about that. This stuff takes time. Let's make sure we get it right now. Fail down here so you don't fail up there. Right? First man, remember? Anyway, what would I do differently after the shuttle program? I don't know, man. I don't know if I'm smart enough to answer that question. Hey, Rhino. I don't know if I'm smart enough to... Yeah, Soyuz 1 happened because of that. Well, Kemerov knew. Yeah, but the Politburo said, launch it or you're dead. And he's like, oh, great. Fly this thing and die, or don't and go to a prison camp. That's good. Well, I don't know if that was the alternative, but yeah. Anyway. How would I have ran the shuttle program after Challenger happens? Ian, I'm with you on that one. I'm with you on that one. I would just keep going. Keep doing what you're doing. Seriously. Assess the failure, figure out why it happened, and keep going. Maybe switch to a 3 SRB design in the future. Or a 3 O-ring design in the future. Would probably be good. I mean, it's amazing to me that this was overlooked. And once again, I have the benefit of hindsight. But the shuttle was supposed to be an all-weather launch vehicle launching literally once a week. They wanted to make the shuttle like an airplane, right? You want to make the shuttle... Can airplanes take off in the snow? Yeah, sure. Does wind keep airplanes on the ground from time to time? Yeah, of course. But the fact that you wouldn't... And once again, you know... It might be because I'm standing on the shoulder of giants here, you know, like it's hindsight, so it might be easy to spot, but, you know, you're designing a vehicle to launch in all weather. It was supposed to launch from California and Florida. You'd think they would have taken that into account at some point. And maybe the thing is that maybe they probably did. From the stories I've read from Morton Thiokol engineers, they did, and there was just really no good way to hard start an SRB in the cold. You know? Also, make sure the people who caused Challenger are held accountable. Well, unfortunately, with bureaucracy, it's really hard to assign accountability, Torlav. But, yeah, I mean, like I said, they were under huge pressure to get the shuttle to perform on time. That's not just from Challenger. That's from the entire program. The shuttle was behind by years, guys. It was supposed to fly in 1979, and they had problems with tile adhesion, and that delayed the program by 2 years. Yeah, the whole shuttle program was rushed, and it's crazy because it's still an awesome piece of equipment. I'm sorry for my language, but I think NASA lost it after Challenger. They should have figured out what happened and pushed the same, if not harder, to prove themselves. Agreed. Yeah, goalie, that's basically what I would have done. I would have kept going with the shuttle program. I would have kept going. I would have kept going. The shuttle would still be flying today. They shouldn't have stopped flying it, first of all. But yeah, I would keep going. I would keep going with the MMU. I would keep going with Shuttle Centaur. I would keep going. Like I said, the 3 O-ring SRB would probably be a good decision. Whitney, thank you for the raid. I do appreciate it. Yeah. You know what I probably would have done, and this, I can't say that I would have done this at the time. This is another, you would have done this because you have the hindsight of it. I would have made the shuttle able to fly autonomously for more rapid prototyping. And that I wouldn't have stopped development on the shuttle at all. Like, there's this thing about safety in engineering, guys. There's this thing about safety. So, and once again, we have Challenger to thank for this. So maybe that needed to happen. I don't know. How do you define something as safe? How do you define it as safe? What's safe? What does that mean? It's something that people talk about, and this is it comes back to what's called risk aversion, okay? So basically, how willing are you to play Russian roulette? You know what I mean? How willing are you to put take a revolver zzz, and, start clicking it until a bullet goes off, right? But if like if you're playing Russian roulette and because you looked at you checked the revolver, there's nothing in it, then, I still wouldn't do that, but, right? You don't want to, like, don't even take the chance. And that's what I mean. That like, how willing are you to roll the dice? Well, that really depends. Risk aversion really depends. How well do we understand the system? So, how safety is perceived is based off of risk aversion. And how risk aversion works is basically, well, how well do you understand what you made? How well do you understand what you frickin' put together? I would say that Challenger was very unsafe. It was very unsafe because there's SRB blow-by. That's not an intended thing for the shuttle to do. You don't want it to do that. The rocket's literally doing something that you do not want it to do. That's not good. That's bad. When you don't understand what you've created, you create a monster, right? Frankenstein, I've created a monster. That's not good. That's not a good thing. Now, with that being said, something that's safer is something... What's safe? Is a 747 safe? 747 is very safe. Why? Why is it very safe? Because it's very well understood what that thing does. It's very well understood. The only thing that's going to put that thing into the ground is if someone messes up. And that usually has nothing to do with the plane. Right? Pilot error usually is why one of those things goes down. God forbid, I wouldn't want that. Right? So, that risk aversion comes from understanding of what you made. It comes from maturing the technology and understanding what you made, and that comes from testing. All right, that has a lot to do with it. You want to do the math out for what you want to make, then make the damn thing, and then test it to make sure that what you did matches the math, and then keep doing that until you're sure you know what it's going to do, right? I'll apply this logic to... I'm trying to find something... Okay, here, we can use this hand sanitizer, right? Okay. Somebody at some point did the math for how much fluid this is going to move out of the bottle, right? How much fluid do you get from pushing down this much, right? Somebody did the math out, and then you test it. I know what's going to happen with this thing. This bottle of hand sanitizer is very safe. Why? Because I understand what this does, and I know what it does. Okay? What's going to happen if you... Of course it went everywhere. That's fine. We know what it does. The thing is, doing this with a 1,000,000-part space shuttle is a little bit more complicated. What a mess. It's just hand sanitizer. We understand what it does, so it's not that big of a deal, right? So, you have to do that with every single component, but the problem is, is this thing designed to work in snow? Like, if I threw it outside right now and put it outside in the blizzard and then tried to use it, it probably wouldn't work very well, right? That's an unknown. That's unknown. We don't know what that's going to do. Why? Because the people who built this and engineered this thing probably didn't really think of that, right? That's where the dynamics comes from in aerodynamics. So, you have to understand what you made. And if you understand it and the technology is mature and reliable, it's safer. All right? Now, if there are unknown unknowns, like with the space shuttle, like with Apollo 13, the unknown unknowns came from when you drop the life support system on the ground and then just say, oh yeah, it's fine. When it comes to something like the space shuttle, right? They were trying to operate it like an airplane, so the more you fly it, the better. The more you fly it, the more you understand. And the data was telling them that the O-rings are probably need to be fixed, and they just ignored that part. So the shuttle could have been made safer right out of the gates if somebody had pulled their head out of their tail, right? So where would I have gone with the shuttle? Like, going back to all this, I would have... Keep flying it. Keep flying. Keep flying. Don't try to put a launch escape system on it. That's not what it's designed to do. You're introducing more unknown unknowns if you put a launch escape system on a vehicle retroactively that was never designed for it. That's how you get people killed. The only solution was to keep flying. Keep flying the thing. Keep flying the thing. Keep building shuttles. Seriously, keep building shuttles. Retire. Do it like Falcon 9. Seriously. Retire a shuttle after 10 missions. Send it back to the factory. Take it apart. Understand what the hell it's doing. Take the whole freaking thing apart. I don't care. But, see, once again, that would have cost a lot of money. No, I mean, and don't get me wrong, NASA probably did this, but it seems, and there could be some variables that I'm not taking into account, which is why I say I don't know if I can answer this question. There seems to be, that, I mean, dude, NASA definitely did that. They definitely did that. There's no way that they wouldn't have done that. What I think happened is that NASA's judgment on risk adversity and how risk adverse they were went up exponentially after Challenger. They weren't willing to take as much of a risk because they killed 7 people in a very high profile way. Not good. Not good. So, yeah, and the public opinion to them was not too good. And public opinion is funding. So what like I said, that's what I mean. What would I have done? There's not much you can do. Powers that be, public perception went down the tube, and then once politicians get wind of that, that's the end of that. You know what I mean? Like, so. Like, you basically had a 747, and the 747 had a problem, and they said, you need to make it safer. All right, we can make it safer by giving it 2 engines instead of 4. So now you have a vehicle that's never going to reach its maximum potential because it has one hand behind its back, and that was the rest of the shuttle program, which really sucks. If you wanted to do reuse and you wanted to do it right, SpaceX is doing it right. They should have made more orbiters. Every orbiter, Columbia, after the first, they ran 4 orbital flight tests and that's it. There's no way you can validate systems that fast. Space is too dynamic of an environment. There's no way. Like, I don't. 4 flight tests, that's it, and then just kind of shoot from the hip for the rest of the shuttle program, like. I don't know, man. Yeah, pretty much, Oba. Very high profile. Yeah, Kyron, they needed to make more orbiters. They needed to fly it more, not less. That would have been the way to make it safer, and that's why unmanned capability with the thing probably should have been there. Or, I don't know. Yeah, I mean, the only solution was to fly it more, and unfortunately, with the position that NASA was in probably at the time, flying it more would have probably gotten flying it more. And not taking a step back to try and make it a little bit safer, especially after Challenger, probably would have gotten more people killed. Yeah. Pink, maybe. I don't know. I gotta sneeze. It's turbo. But yeah, that's a real important thing to understand, dudes. Risk aversion. How willing are you to roll the dice? How willing are you to roll the dice when it's not in your favor? You're gambling. Shouldn't gamble with people's lives like that. But once again, the most important thing to understand from all this is that I'm telling you this with the benefit of hindsight. I'm telling you this because I've read the Rogers Commission. I'm telling you this because I didn't live through Challenger, but I've watched it a bajillion freaking times. Would we even be talking about this if Challenger had flown just fine? It's hard. That was my thing with the ASAP report from the other day. They criticized Boeing for not recognizing that a problem exists before Boeing found a problem with the capsule. And then they published that in a report. It turns out that they were wrong, which is hilarious to me. They were wrong because it's so easy to say in hindsight that there's a problem up until that point. And the ASAP actually revised their statement and they clarified that they were talking about something different. But they only did that after Boeing said, you have no idea what you're talking about. And NASA said the same thing. Yeah, Matt, everything's good. Had Challenger not happened, the U.S. space program would be completely different today. Roblox, that's what bothers me the most. That's what bothers me the most. Is that NASA went from the Apollo missions to having your head so far up your tail, or having a politician's hands so far up your tail, let me put it to you like that, that all the signs were there. The engineering doesn't lie. The data doesn't lie. It doesn't. You can't, physics laws don't change. All the data was there. All the data was there to make the shuttle safer before Challenger happened. All of it was there. And nobody batted an eye. Everyone's like, yeah, nah, never mind. All of it was there. That's what bothers me the most. Because, dude, the shuttle could have been it, man. It could have been it. It could have been it, dude. And what do I mean by it? It could have been the launch vehicle. That thing, dude, the shuttle was capable of doing legendary things. Half the things that they designed that thing to do from the start, NASA ended up never doing because it wasn't safe. That's what bothers me the most. Actually, scratch that. That's the things that bothers me the second most. The thing that bothers me the most is we lost 7 astronauts for no reason. That's up at the top. Should have kept the Saturn V and done the shuttle in parallel. Yeah, and Devlin, this is what I mean. That's what I mean when I said that you have... NASA had a politician's hand so far up their tailpipe that they couldn't do anything, right? They kind of, like I said, NASA got forced into that position. It wasn't NASA that... Yeah, like this is why it's so hard to assign blame, because it's not really NASA's fault. What do you think happens if you cut their budget by 80%? What do you think's going to happen? You cut NASA's budget by 80% and tell them to do more with less? More with less is not a thing that logic need not apply to spaceflight. You don't do more with less. That's stupid. That's how people get killed. Nice, Hired. That's cool. So, I mean, once again, the Challenger, the events for Challenger, and the inevitability of a shuttle malfunctioning, that was set in motion years prior to that happening. There's a lot of static between engineers and the management who just don't get how stuff works. Yeah, Kiranov, that's not necessarily what happened with Challenger, though. That's not necessarily what happened. I'd say that... And once again, I have the benefit of hindsight, so this isn't some crazy revelation, guys. The shuttle program has dude, there's all kinds of stuff. There's all kinds of stuff.
Discovery, go and throttle up.
There's all kinds of stuff that needs to be like so what's the right way to say it? The testing was not sufficient enough for the shuttle. And it's not because NASA didn't know what they were doing, okay? The testing was enough because the testing wasn't good enough because you're trying to build the most complicated spacecraft ever and you're trying to do it with the Gemini program's budget. That's the problem. You can't say NASA's going to do this and then don't give them the money to do this. That's my thing with the shuttle program. Shuttle was amazing. I firmly think the shuttle could have been made to be just as reliable as any airplane. Absolutely. It would have taken a lot of time. It would have taken a lot of effort. It would have taken a lot of money. Money that NASA didn't have. Dude, all right, fellas, play this one off. Play this one off your mind for a second. NASA's budget got cut so hard in 1971, 72, and 73. So hard that built Saturn V missions that you had astronauts trained for didn't fly. Built Saturn V's, did not fly. Built LEMs, built Apollo modules, did not fly. That's how hard the budget cuts hit NASA. What do you... And now you want them to develop the shuttle? And the Saturn V's are sitting in museums. That's correct, Kev. That's all the Saturn V museums we have. Why do you think we have so many of them? Because they quite literally pulled the plug on the Apollo program. Real bad. Hey, weather guy, what's up? Cloud Rule's killing that CSG-2 mission today. Thick clouds, boy. So that's what I mean. That's my beef with the shuttle program. Dude, that's not how development scales work, even by NASA's own admission. Your funding peaks during development. The shuttle's funding peaked way after development. Way after development. They penny pinched during development of the shuttle and then increased its budget when it started flying. Okay. So devil's advocate here. At least we have Saturn V's in museums. Yeah, true. Al Desert, nice. So, why was the shuttle's post-flight refurbishment so extensive compared to how they envisioned it at the start of the program? Torlab, this is why the question about what would I have done with the shuttle program is such a hard question to answer. Long story short, you're flying the shuttle. You don't fly it a lot. It flies after Challenger. The peak flight rate was maybe 4 flights a year. The shuttle was envisioned to fly 48 times a year, by the way. 4. So, infrequency of flight. So it's been 3 months. This thing has been... You have 3 months between each mission. You want to be sure that this thing works correctly? Take the whole engine apart and put it back together. Basically like the engine is brand new. And that way you can be absolutely sure that the engine doesn't malfunction. This is what I mean, dude. This is what I mean about engineering. Like, this is how badly the budget got cut during the shuttle program. Those RS-25s, the SSMEs, were designed to fly for 55 flights with no refurbishment. 55. One. Yeah, one. Because that's what I mean about... That's like the risk aversion. The risk aversion. Could you fly it again without taking it apart? Yeah. You could. Do you want to risk a failure? No, you don't. You don't want to get more people hurt. So the right move is to, and you don't want to risk more lives, right? Well, I just said that, but so the only real solution is just to take the whole orbiter apart and put it back together. That's how the shuttle program stayed from like 1988 basically all the way up until 2011. And then Aerojet, oh, dude, that pissed me off so much, Buck. Aerojet Rocketdyne back in 2018 tested a off-the-shelf shuttle engine. They basically took off-the-shelf shuttle parts. Oh, dude, this is what, oh my God, I can't believe this happened. Oh, I forgot about that. So, Aerojet Rocketdyne had this program called the AR-22 program. The AR-22 program was taking existing Block 2 SSME parts, putting them together and making an RS-25 engine, basically making an AR-22, which was a modified. It was a not modified shuttle engine. The reason why it's called the AR-22 is because this program was designed to see how reusable a shuttle engine is. And they took this AR-22 engine, which is made out of leftover shuttle engine parts, so Block 2 SSMEs, and they put it on the A2 test stand at Stennis and fired it 10 times in 10 days. No refurbishment between flights, or between firings. Ten times, 10 days, full duration burns. The RS-25s are reusable. They're reusable. That pretty much proved it. Now, two things. It's not always that simple. Two things. I believe their full duration burns weren't as long as the shuttle's burn, and that could mess things up with the motor. The shuttle's engines were burning for 8 minutes. I think they were testing like 6 minutes or something. So that could have done something. That could have been a thing. So maybe they're not putting the engine through as big of a duty cycle, which could be a thing. But also at the same time, 10 times in 10 days. Basically illustrating that those shuttle engines can be fired a bunch of times with minimal refurbishment or no refurbishment, and it's not that big of a deal. Duty. Yeah, they did that for the Phantom Express project. Yeah, which ultimately got canned, but that's okay. If shuttle engines are designed to fly 55 times, why are they used on SLS? Aren't they over-engineered for an expendable rocket? Oh boy, here we go. Why are they on SLS? Good question. Couple of reasons. First and foremost, the reason why they're on SLS is because we decided when the SLS program came around that we didn't want to make a super heavy, uncrewed cargo launch vehicle. So they basically didn't want to make Ares 5, and they wanted to go back to putting people on top of a super heavy launch vehicle like the Saturn V. So, because they wanted to human rate the super heavy launch vehicle, because they wanted to save money by making the heavy launch vehicle, the super heavy launch vehicle, more complicated. Wait, I'm going to say that again. They wanted to save money, so they made the super heavy launch vehicle more complicated. Yeah, that... Okay. I'm not making... It's true. So... The Ares 5 from the Constellation program was supposed to have RS-68s in it. Now, this is the second part. RS-68s have an ablative nozzle. The nozzle on an RS-68 in an RS-68A is literally made out of heat shield. The reason why it's made out of heat shield is because of cost. RS-68s use open cycle. They have twin power packs, 2 turbo pumps, 1 for LOX, 1 for hydrogen, open cycle. It's a much simpler design. However, because you're using an ablative nozzle, right? The nozzles really don't like having heat exposed to them from the outside. The inside of the nozzle is just fine. But if you expose the outside of the nozzle to heat, a la other engines firing next to it, you're going to have a little bit of a bad day. Ares 5 had 5 RS-68s in the first stage and 2 5-segment SRBs. There would have been heating problems with the RS-68. Those heating problems, not well fixable, right? Yeah, you could have fixed that. You could have given it a regeneratively cooled nozzle, but that would require re-engineering the RS-68 basically from the ground up to make it a closed cycle engine, which would have cost a lot of money. At the time, and don't get me wrong, I'm not going to say, I don't think this is a smart decision by any means. At the time, they wanted to save money. Constellation was too expensive, too expensive. Whatever that means. So they thought it would be easier since they were human rating. They wanted to put Orion on top of Ares 5, that it would be easier to put RS-25s on it. It would be easier to just put shuttle engines on it. And you already have shuttle engines left over because of the shuttle program. They thought they were going to save money that way, rather than redesigning a variant of the RS-68 that would be able to take the heating of having those two SRBs next to each other. Now, the other thing, so, okay, how does the shuttle engine deal with the heat? Well, the shuttle engine's regeneratively cooled. It uses liquid hydrogen in a fuel-rich staged combustion cycle to keep the nozzle cool. It's the other reason why you can reuse those things, because the nozzle doesn't eat itself from the inside out like it does on an RS-68. Do you think SLS will be NASA's last rocket they ever operate? No. No, Kev. I think NASA's going to make more in-house rockets in the future, if you really want my honest opinion. You know, it always sounds counterproductive to try and save money if something is government-funded. Signer, that's not always the case, guys. I'm starting to see a pattern here, saving money, then spending more money to save that money, and I don't like it. Yes. That's the thing with, and that's my $30 billion meme. We saved $30 billion at the very least to spend $40 billion later. It is the most counterintuitive argument I've ever heard in my life. The people that come up with this are I don't know. I don't know what to say. I don't really know what to say about that. The people that come up with this stuff are nuts. Like, that's the stupidest thing I've ever heard. And it's funny because, you know, the folks that came up with this stuff are hailed as, you know, geniuses because they funded the Commercial Crew Program and stuff, right? But the funny thing is the Commercial Crew Program wasn't even these folks' idea. The Commercial Crew Program and Commercial Orbital Transport Services were part of the Constellation Program. It's hilarious. I'm not making this up. You can go look it up if you want. They didn't even... They just canceled parts of the Constellation Program and made arguably a much more expensive launch vehicle and then pawned off low Earth orbit to commercial, which at the time seemed like a very, very big stretch goal. So, yeah, I mean, so why is SLS using shuttle engines? Well, because they wanted to put people on it, and because it would have had heating problems. Solid rocket boosters make a lot of heat. I mean, so do shuttle engines, but shuttle engines were engineered to work close next to each other because of the shuttle, right? They did a lot of testing with the shuttle. So they knew that they could operate them close to each other, which is cool. Guys, it's annoying because the back of SLS, the engine section, is basically a cylindric shuttle aft end with nitrogen CAPUs instead of hydrazine APUs. They're using core stage auxiliary power units that are nitrogen actuated, not hydrazine actuated, because they're one-time use. But that's a whole nother story. Yeah, of course, Forge. Yeah, I mean, duh. Yeah. Do you have the link to the Constellation proposal that pointed that out? I lost my manual somewhere. Blue, I'd have to go looking. Excuse me. They literally took the shuttle's tail end and put it on the bottom of SLS and made it a cylindric shape, T-Man. Yes, that's what yeah. Anyway, Bobby, what's this next one? Was Congress members wanting to reintroduce work in their districts a large reason for the SSMEs on SLS? Yeah, yes and no, Bobby. Okay, so the Constellation program was basically designed to take most shuttle personnel and move them to the Constellation program. They were gradually moving people over. They ramped down the shuttle program. You keep your technical knowledge base, right? Keep all your engineers, same guys doing the same things, right? And move them over to Constellation slowly. When there was wind of Constellation being canceled, first of all, it was done without congressional approval because the executive branch controls what NASA does. When Congress got wind of this, they freaked the frick out. you want to cancel a program that literally involves almost every single NASA center. Congress freaked out. And Bill Nelson was one of the people that freaked out because that's thousands of jobs lost in his congressional district. They freaked out. So they scrambled to make the shuttle, to help get a shuttle-derived launch vehicle on the table to try and save some of those jobs. They were actually helping people keep their job for a change in regards to Constellation getting canceled. And the reason why SLS uses a lot of shuttle-derived parts, one, to save money, but the reason why, people say, I hear this all the time, oh, it's just a jobs program, it's just a job. Yeah, what NASA program isn't? Second of all, they scrambled after they panicked, basically, after when they got wind of wanting to pull the plug on the Constellation program. Guys, the Constellation program had full support. Both houses. Or both chambers of Congress. They had full support across the board. Yeah. Oh, yeah. Congress freaked out. They freaked the frick out. That's part of the reason why SLS is using leftover shuttle parts. Because the Constellation program had a very clear path to keep everybody happy. Architecture spread out. Everything was good. Just like the Apollo program. It was basically putting NASA back to doing what it was supposed to do. And once again, once Congress got word that, that wasn't going to happen anymore, they freaked out. So, yeah, Bobby, part of the reason why SLS has leftover shuttle parts in there is because of that reaction. Cancellation program. Oh, you're killing me, dude. You're killing me. Thousands of jobs in high tax rate. Yeah, and you know what the funny thing is? You guys want to know another reason why SLS is taking so long? They scrambled to get all those shuttle-derived parts, for SLS. And while that was happening, they canceled the shuttle program. Yeah. So all the people that worked on the shuttle program, they fired. Literally the day after SDS-135 touchdown. Yeah. Okay. Oh my God. They fired for like 5,000 people from Kennedy Space Center on like July 21st, 2011. Oh yeah. Laid them all off. So, yeah. Congress scrambled to try and save the jobs, and while they were scrambling trying to save jobs, they canceled the shuttle program and screwed all those people out of work. How's NASA budget determined? NASA's budget is entirely determined, dethroned from public opinion. If the public thinks NASA's good, politicians pick up on that and they'll fund it. This is very highly evidenced from SpaceX's success in the 5 years ago, and NASA's budget getting increased. Because the public was seeing what SpaceX is doing and saying, oh, we need NASA to do that too. And they increased the budget. Funny how that works. Jim Bridenstine, through his tenure, got NASA's budget increased by $3 billion and got a human lander on the books. Yeah, that human lander ended up being SpaceX, which is kind of funny, but hey, he did it. Lead on the SLS program after the entire SDS team is laid off. You did what? Pretty much, Devlin. Yeah. Mm-hmm. You got to be a weirdo to dislike NASA. Well, Sasquatch, some people out there don't see it as a useful... Some people out there don't see it as a useful thing for our tax dollars. I disagree. I think it's one of the most useful things. Not NASA's fault they didn't fund a single lander in its entirety. I mean, the SLS is literally made out of the scraps of the Constellation program, which is coming back to bite us now because we have a rocket, and the first stage is amazing, but we literally have a super heavy launch vehicle first stage in the core stage in the SRBs, and we have a medium duty launch vehicle second stage on top of it. Don't get me wrong, the ICPS is a great stage. And I understand why they did it that way, because they thought that was the best path at the time. Once again, they panicked. They panicked and Bill Nelson was one of the people that helped get this done. They panicked and got SLS on the table and passed it, right? And basically said, the hell, you're going to cancel the Constellation program. No freaking way you're going to. And we got a compromised architecture as a result. Have we heard any EUS updates recently? We saw the Universal Stage Adapter the other day, Blueland. Can you check this PDF for me? Okay. I've seen this PDF plenty of times. What are you talking about? Homer Hickam said it best. Interim or temporary in spaceflight does not mean temporary in the long run. He's right. Well said, Ian. Yeah, and Homer, too. Yep. Who canceled the Constellation program? I won't name names, but NASA's direction and their goals are set by the executive branch of the United States. What's that on page 14? Throwback to Artemis 2 with the EUS. I mean, we've been trying to pick up the pieces since. Trying to pick up the pieces since. Pain in the butt. What's on page 14? What am I looking at here? Page 4. Oh, 14. SLS's go for 2033 crewed Mars flyby. That looks like a Gateway-derived transfer vehicle. Gateway-derived Martian transfer vehicle. Yes, Kev, that's right. NASA's budget from... So, one of the big things that set NASA back kind of not on the right track, but going right in the right track direction. This is why I'm so positive about SLS all the time, because I was very critical of it until about 2016. And, well, 2015, 2016, somewhere around there. And then in 2017, the NASA Transitional Authorization Act passed, and that basically it was a funding increase for NASA, and it was a huge funding increase for the SLS program. But the Transitional Authorization Act of 2017 really solidified what SLS needs to do. It didn't really have a mission up until then, so they gave it something to do. Which, once again, people use that. I see that in like op-ed pieces about spaceflight, and people say, it's a rocket with no mission. It's a rocket with no mission. And then when they give it something to do, people say, oh, it's a rocket. they had to fund it to give it a mission to do. It's like, isn't that what you wanted? Hello? Isn't that what you wanted? So they gave it a mission from the Transitional Authorization Act of 2017. It gave it a mission. And that's what got the Artemis program on the books, and that's what got us the human landing system and stuff. And that ultimately led to NASA's budget getting increased by $4 billion. And the crazy thing about that is that momentum from the Artemis program did not just increase. That was not just an increase for human spaceflight. That was for Earth sciences too, for climate observatories, for climate monitoring satellites like Sentinel-6, for instance, which did end up launching on a Falcon 9 a couple of years ago. That was a couple of years ago at this point. So yeah, it was across the board funding. I mean, I think what they planned on doing at the time was getting rid of NASA's STEM program, and that it probably wasn't the best thing to do. But honestly, if it means more funding for like climate science, Earth science, human spaceflight, going back to the moon, I don't know. Would you guys take that trade? You tell me. No? Interesting. Would you cut NASA's STEM funding if it meant getting more funding for like human spaceflight, climate science research, earth science research, planetary science, like basically everything else? I don't know, guys. It's a quandary because you cut NASA's STEM program. That means you're not giving people a pretty well and clear pathway for like younger kids to want to work for NASA, right? But on the other hand, you know, the STEM program helps, you know, basically show people that NASA is a viable job path. It helps inspire people to get into science, technology, engineering, and math, and maybe a job at NASA in the future. That's a very useful resource. I agree with that, but I can't help but think in the back of my mind that you want to know what the best outreach for NASA is? Launching rockets. That probably would get you a better return. Like, I don't know. I'd take the funding, man. Like, as messed up as that sounds, you know, like I'm not happy, you know, not happy about it. It's true. Roll back the laws like how NASA is not available to advertise and outreach. The blackness, that doesn't matter anymore. SpaceX does all the advertising for them by launching rockets. I'm noticing a trend here. Excuse me, one hop. There's more to STEM outreach than just trying to get people interested. Oh, of course there is, Buck. Isn't NASA STEM budget less than... Yeah, yeah, Spartan, that's the other thing. I mean, it was a little bit of a funding decrease for a funding increase everywhere else, and people said no. Nah, I don't know. I agree, and that's the best thing we can do. One moon, yep. Mm-hmm. So, yeah, I mean, guys, that kind of... The thing about Challenger kind of turned into a long conversation, but I mean, I was just playing off your questions. But yeah, long story short, you know, SLS isn't the best architecture, but it's good enough. It's what we have, so let's make sure we don't Challenger more people. Yeah, Philister, I don't know. But yeah, I didn't mean to get this into a funding thing about NASA, guys. But yeah, it was important to understand. But hey, guys, see, here's the thing. We can talk about budget this. We can talk about SLS that. NASA's budget is increased. It's still increasing. It's from the momentum from the 2017 Transitional Authorization Act. Basically, when Bill got in there, he used it as a springboard. You know why? Because he helped come up with it. It's the best part. It's the best part. We don't have to choose anymore. So, like, don't think everything is hopeless. It's not. It's absolutely not. On the contrary, man. We have Starship and SLS being developed. So we're not going to only have one way to get back to the moon. We're going to have two. So, I mean, yeah, canceling Constellation sucked. It was not good. But it put us in a very unique scenario where like, Shuttle 2.0 and Saturn V 2.0 are being developed at the same time. Like, and will work together to go back to the moon. That's pretty cool. I like that, and we didn't even need to raid the STEM budget to do it, you know? Like, I'm cool with that, man. That's fine with me. Let's keep doing this, please, you know? Yeah, Buck, I'm with you on that one. NASA, we shouldn't have to choose. It's not... Everything that NASA does is vital. It's vital. It's not there for no reason. Anybody who suggests otherwise is an idiot. NASA just needs more money. More money to do all the things, right? Do the other things. So, we good. And for the people who say, oh, NASA needs the military's budget. No, they don't. What they have right now is fine. I mean, I'm not gonna sit here and say like doubling NASA's budget wouldn't be really nice. Doubling it would be perfect. We could get like a moon base figured out for double the budget easily. Hey, Roundabout, what's up, dude? Yeah, 04, I think NASA should have redundant capabilities to SpaceX. There, I said it. It's true. Doubling the human spaceflight force. No, Hellfish, you're not thinking about that right, dude. No one's gonna go for just increasing NASA's budget for just human spaceflight. No one's gonna go for that. Here's the 5-head move. You know what the 5-head move is? Build a climate observation constellation for monitoring their climate with modular satellites that can be upgraded that require manned spaceflight for servicing. You fund the launch vehicle, the satellites, the capsule, all in one shot. Increase the budget across the board. Everybody gets on board. Everybody likes this idea. Because now you can keep upgrading the satellites, and over time, you don't need to pay as much money to buy a new climate observation satellite every time you come up with a new piece of climate sensing equipment, right? And you keep the rockets flying on a regular basis to maintain said infrastructure. And you work on modular spaceflight techniques, which means building space stations, gateways, stuff like that. That's the 5-head move. That's the 5-head move. Build a climate satellite constellation. Like Sentinel or Landsat or something, and have something like Starship maintain it. Heck, have something like Starship go up there, drop off a satellite, Landsat 10, and then bring Landsat 9 back down, and then upgrade Landsat 9, and then send it back up. I think they tried to do this once before. What was the name of that vehicle? Oh, the space shuttle. That's what started this conversation. That's funny. See what I mean about the space shuttle's potential not being tapped into? Yeah, it's pretty crazy. Could have done a lot of cool things with that. Whatever. Starship will do it. The Astro van space truck or something, Ian? I don't know. Began with an S. Yeah, that space shuttle. Yeah, that would have been nice. That would have been pretty good, don't you think? Wouldn't we be better off having Starship support a lunar colony? Yeah, roundabout. Fellas, the point that I'm trying to get at here, is if you buy a 747, right? You buy a 747, and its initial purpose is to move people around. Does that mean you can't move stuff around in it too? Nope, it's just a passenger plane. No. If Starship could be built to maintain a satellite constellation, right, and you're building a vehicle that big, getting to the moon is easy. You're not, this is what I mean, you're not thinking about this. Starship is going to need to practice refueling and not rearming, that's not the right word. They're going to need to practice refueling, replenishing commodities on this, so every time Starship would go up and maintain one of these satellites or bring it down, you get experience with on-orbit operations. You get experience with refueling. You get experience with rendezvous. You get experience with docking. You're not thinking about that right. That's all precursor stuff. That's literally a Gemini program for Starship to be able to get to the moon. See what I'm talking about? You're not thinking that's what I mean. Dude, it's engineering. You can do a lot of stuff with this. Rearming those tungsten rods. I don't know what you're talking about. Excuse me, sir. I'm American. I like the idea of rearming something. Yeah, rearming it with science. Boom. Got him. Yeah, so, once again, on January 28th today, guys, the 36th anniversary Challenger, it's important to understand how we got here and why. All right, that's the biggest thing to take away from this. I didn't mean getting up on the soapbox there, fellas. Sorry about that. It's just kind of where it went. I wanted a space elevator, then I saw what happens if it were to fall back to Earth. Yeah. Yeah. Okay. Rearming me with science! Yeah, right. Armed with humanitarian missions. Floating, you have no idea. Dude, you have no idea. Go read the Transcom PDF about what they want to do with Starship. It's pretty good, man. It's pretty cool. It's pretty cool. I don't like admitting that because you know it's not gonna be just humanitarian supplies, man. There is some insane stuff planned, dude. It's pretty cool, man. It's pretty neat. Yeah, roundabout. It is what it is, dude. And like I said, it's important to just not honor the lives of the 7 people that were lost, right? The 7 astronauts that were lost. It's important to understand, the historical context of it, how it happened, why it happened, what was going on, and the lessons learned. Because, we don't learn the lessons from that. Basically, if the launch window says don't launch, you don't launch. Just like what happened with SpaceX and CSG-2 today. They saw, man, clouds are too thick. We'll launch tomorrow. Screw that. You got to learn from this or else their deaths are in vain. And we did. We did learn. And, arguably we're better off, Space travel is not without risk. Oh, absolutely. Talma, duh. Of course. But there's risk, doing something risky in space. The Apollo program. And then there's just being lazy. Oh, the shuttle really can't launch today. It's too cold and it's too windy. Yeah, I'll launch it anyway. Of course. There's risk. There's always risk. But spaceflight isn't about being a goddamn lemming. You know what I mean? Very, 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 very avoidable risks, Jay. Once again, we were talking about it a little earlier. That's what bothers me the most about Challenger. It's so easily preventable, dude. Challenger is the equivalent, and that's what I started the conversation with this. Challenger is the equivalent of blowing a stop sign. There's a stop sign. You should stop the car. Can you keep going? Sure. Why not? Do you want to risk that? No. What if there's a truck coming and you get wrecked by a truck? Do you want that? I don't want that. But there's also a chance that if you step on the gas and go through the stop sign, you'll be 100% okay. Do you want to roll the dice like that? That's stupid risk. That's being an idiot. That's not the risk adversity that comes with space just being inherently dangerous. No, space is always trying to kill you at all times. It's dangerous enough. You don't need to add risk on top of the risk that's already there. You don't need to let's make it more risky. Sure, why not? You know what I'm saying, man? Let's make it more risky. Frick it. It's fine. It's okay. This is more risky. Oh, 7 people got killed. Oops. You don't want to do that. That's not a good idea. Do a flip. Yeah, right? Anyway, so SpaceX launch got scrubbed. It's like comparing space to my summer car. Yeah, kind of. I almost got wailed on by that train, huh? I watched a documentary about Challenger. Some people should have been put to jail. Dio, it's more complicated than that. It always is. Back-to-back launches this weekend now. That's what I'm talking about, Kev. Hell yeah. Cool little fact that this booster was supposed to launch. Cool little fact. This booster that was supposed to launch was a Falcon Heavy core. Oh, neat. All right, guys, let's see. What else do we have here? All right. We'll get back into the rest of the space news here. My Summer Pudding City. There's a source selection statement for commercial low Earth orbit destinations, guys. Speaking of Starship, CLEOD is a NASA program that's being funded for commercial space stations to replace the ISS in the 2030s when NASA, starts going out to the moon and Mars, right? Check this out. It's interesting because SpaceX's proposal is in here because they proposed something for the program. Very high level of confidence, high level of confidence, moderate level of confidence, low level, very low level. So B is what we want. Are you going to the mall later is not what we want. Yeah, there's your level of confidence rating. Okay. Where's the proposals? Let's see. So, initial evaluation, there's NanoRacks, Space Villages, Northrop Grumman, Blue, OAC, Think Orbital, Maverick, SpaceX. All right, let's see. I was interested in this part. Let's see. For the technical approach evaluation, SpaceX received a level of confidence rating of yellow. Its significant strengths included proven speed, safety, and systems engineering and vehicle manufacturing. Its early prototype and demonstration plan for HLS can increase technical maturity on some commercial low Earth orbit destination systems and a comprehensive improvement safety and risk management approach. Its strengths included more than 2 crew members at initial operations, a strong approach to future commercial communications, including the maturity of Starlink, and a proven design and strategy for rendezvous and docking. Its significant weakness included a lack of definition on its CLD concept, a lack of definition for external payload accommodations, a lack of payload capability definition in its proposed conversion of human landing system into a commercial low Earth orbit destination, a lack of detail for scaling up ECLS from a short to long duration capability. Its weaknesses included limited available payload power for its proposed commercial low Earth orbit destination and proposing a single docking part which reduces crew and cargo access to the CLD. Its significant strengths included rapid development of Starship and a planned orbital mission in the coming year, use of in-house development resources, and no dependence on outside suppliers. Its strengths included strong financial resources, which increased the likelihood of successful execution in the event of cost overruns, okay? Commercial low Earth orbit destinations floating. SpaceX hasn't told them anything very useful, Hellfish, because they haven't made any of these things. I just wanted to see what the proposal was. So their proposal is basically taking human landing system and just putting it in low Earth orbit, which is hilarious. Its significant weakness included a lack of business strategy, which fails to meet goals for developing the low Earth orbit economy. Seeking full reimbursement of its narrowly scoped SAA costs from NASA, despite leveraging private financing of Starship. No proposed PDR on its performance design review, preliminary design review, which fails to meet one of the primary goals of the announcement, and milestones do not objectively demonstrate technical or business progress. Its weakness included its high dependence on HLS without addressing it as a risk. Its weakness includes its high dependence on HLS without addressing it as a risk. Now that one I don't understand. How is it a risk if Starship depends on another program that they already have the funding secured for? If something goes wrong with HLS? Maybe? I don't know. I wouldn't call that a risk. I would call that an advantage. Maybe I'm just crazy. Interesting, Pixig. Anything that's not proven would be a risk, yeah. Well, they have the funding. It's not a maturity problem yet. Not fully developed, which is why it's technically a risk, because if Starship HLS fails, this fails. Yeah, okay. Yeah. That makes more sense, Hokie. I guess there's a risk that HLS goes the way of Constellation. Granted, I don't think so. I don't think that's the case. I think it's more of a technical risk at this point because HLS isn't made. But see what Hokie said. What Hokie said is right. He said it better than I did. That's very interesting. Constellation decision was political. Of course it was roundabout, but so was the Apollo program, dude. Careful with that one. You're right. You're absolutely right. It was. But NASA is political. Yeah, it's inherently political. The Apollo program was. So was the Shuttle program. They all are. So, careful about pointing the finger like that, dude. You know? I can't stand it when people say NASA's a jobs program. Yeah, okay. There's a jobs program, implying that it doesn't do anything. That might be true now, but that was not true during the Apollo program. The Apollo program wasn't a jobs program? Oh, what was that? That was just happy-go-lucky time, right? It's just happy-go-lucky time. These aren't jobs. These are things where people come to do things for NASA, and we pay them for doing things at NASA, and they provide a service, and we pay them for said service. You know, they got a word for that. It's called jobs. But yeah, I know. We gotta just be careful about pointing a finger in this day and age, dude. I think that, honestly, dude, I think that hinders an argument more nowadays than anything. If I say that, you know, streetlights are the reason why I crashed my car, right? Streetlights? Your car doesn't have headlights? Well, that's on me, isn't it? Careful, like, I think that hurts your argument, you know what I mean? I don't like blaming people. Blaming people is what people that have no solutions do. You know what I'm talking about? Don't do that. Late night call to say hi. I need to sleep off the good 1,000 kilometers I got in the last 48. 1,000 kilometers? What, are you driving? I thought you were totally going to say prostitution. I mean, that's, you know what? That's a thing that exists that I have zero experience in, Dethrone. I don't have any experience in that. I don't know what you're talking about. They took dirt. All right. So, what else do we got? That was the Starship proposal. Anything else here? This is exactly what a pimp would say. Would he, though? Or she? Holy crap, my house was just rocked by a massive explosion. I think I better go tend to the doggos if something is damaged. Why are you talking to us, Dama? Jesus. Go. Launch with scrub, Vin. Oh, nothing shows up on the scopes. What do you think? Primo is the fem? I don't know. I don't know what... I mean, maybe? I don't know. Any chance you'll take a play of re-entry? An orbital simulator? Llama Dragon, maybe, at some point. You're a pimple. Got him! Yeah, so Cosmo SkyMed got scrubbed, which kind of sucks. 24-hour scrub, from what I understand. You guys want to see what's going on down in Boca Chica? Let's check it out.
Discovery, go at throttle up.
Switching. 29-month resub. Thank you. What cause? Clouds. The jobs revenue thing is bad enough, but the worst is when people say, why are we spending money on space and not Earth? Assuming they freaking load the rockets with wads of cash and launched it. Kev, before we get into this, anytime anybody ever says that, I just say, well, what's the Apollo program then? And they say, oh, we spend a lot of money. Yeah, we spend a lot of money to go to the moon. And then we listen to the people who say what you're saying right now. Where did that get us in space? Nowhere. So, yeah, no, that's a load of crap. We should be doing both of the things at the same time. And we can do both of the things. We're humans. We can multitask. Especially 7 billion of us. We'll be fine. Hey, Popsicle, what's going on? Alright, so, this is the NASA spaceflight footage, dudes. This footage is coming from Mary, Boca Chica gal. Make sure you go over and follow them at NSF. Looks like they got some rain down there. I'm a big software guy. I want to get a job in space. So bad. I have no way of getting that kind of experience. Your software. Dylan? Everyone's looking for software all of the time. You don't necessarily have to be NASA. Go look around. But you're focusing on things that aren't important to me. Fuck, yeah. Dude, yeah, I know. It's ridiculous, right? Like, we can do both of these things. Dude, barking up the spaceflight tree is like saying your electricity bill is the reason why you're broke. Like, the electricity bill, that's the hill you're gonna die on, the electric bill. Not water, not the high price of groceries. That's the hill you're gonna die on? Are you kidding me? There's so many other things that are way more expensive that we spend way more money. You're gonna bark up the spaceflight tree? People do that because it's convenient, all right? It's ridiculous. Yes, this is my hill. The electric bill is why I'm broke. Like, what? What are you saying? If somebody said that to me, I'd be like, you've never paid bills before in your life. What are you talking about? The cable bill is why I'm broke, man. Like, what? What? Stop it. Stop this. You stop this now. Well, the road argument I can understand, Road. I can get that one. That's funny. Are you done playing KSP? No. What? You have cable? Yeah. Cable would have been funnier, right? Stop drinking Starbucks and you wouldn't be broke. Like, see, that's why I chose the electricity bill. It's something that you need. You know what I mean? Oh, man. Yeah, well, a roundabout part of the reason why SpaceX is so dang successful is because they canceled Constellation, man. It's a mixed bag. It's a mixed bag, you know? My Twitch sub is the one that breaks my budget. Oh, God, you're subbed to me. I'm so sorry. I can feel my brain going away. Hey, downcomers. Oh, nope, not downcomers. That's ground service pipes. See the insulation that they have on the pipes? This is designed to move commodities around on the pad. So the insulation on the pad is a dead giveaway that this will be used for cryogenics. So this is like a methane pipe or something. No more avocado toast! But I like that. Doesn't matter. Will they insulate the joints later? I don't know. Hoi Minoi. What's up, Pythos? How you doing? I'm late tired. Well, have a nap. Then fire the missiles. Yeah. Yeah, look, yep, they're moving. See what I mean about cryogenic, good old cryogenic pipes? That's not insulation right there. That's ice. Is that a server room? Why so many AC units? That's the electrical room. See, Kraken? Electrical. So yeah, it is. There's probably a mainframe in there if I had to guess. I know it's the electrical room because I've watched this pad get built from a swamp to this, right? You should have seen how many wires they ran over there. There is thousands of conduits coming out of the ground underneath that building. So I'm going to say that that's the powerhouse for the pad. So there's probably something in there that generates a lot of heat. Sizep, 51-month resub. That's, yeah, you can tell it's really cold right here because of the way it is. Yeah, that's the insulation right there. That's not insulation. Damn, dude, look at all the ice form on that thing. That's crazy. Doing okay. Got myself some breathing space. The car has been extended until March so I can get my emissions has been verified. Oh, nice. Dang it, I want a LOX cooled PC now? No, you don't. No, you do not want a LOX cooled PC. It'll rust in like a week. You use nitrogen. Use something non-reactive. Liquid nitrogen, much better for cooling. Much better for cooling. Yeah, LOX also likes to make things blow up real good. I had no idea that ice meant cold. That's a lot of ice. But warmer. Okay. Fine, I won't go AMD. We already talked about controversial things today, guys. Can we stop? Can we not bring PC parts into this, please, for the love of God? Please. This thing's a monster, dude. It's a freaking monster. So, how do they prevent the plumbing to rust? Hater, what's one of the last things that Falcon 9 does before it launches? You've watched plenty of launches with me commentating over it. What's the last thing it does? You know this. I know you know the answer to this. They vent the propellants. They vent the propellants out of the strongback. You know why they do that? To get the LOX out, because it will corrode the pipes. The rocket engines do that, guys. Watch the Merlin engines next time, well, tomorrow, hopefully, when we watch the Falcon land. If the footage is clean enough, the Falcon 9 will come down, they'll vent the tanks down, and then the engines will purge out. They purge the engines with nitrogen. They just basically run nitrogen all through the engine, and it comes out the nozzle, and it comes out a couple of vent lines. The reason why they do that, don't keep LOX in the engine. Bad idea. Yeah, very bad idea. The LOX is extremely corrosive. It's liquid oxygen, and it oxidizes things. It makes things rust real badly. Yeah, oxygen oxidizes. I know. Right? So, yeah, Hater, they vent the gases out on purpose. And SpaceX, they do a chill down. They only fill it up with LOX for a second, and then they purge it out with inert gas that's non-reactive. They purge it out with nitrogen to make sure that it doesn't rust. The shuttle engines needed to do the same thing. Now, when the shuttle engines launched up into space, they're up in the vacuum, so they dried out, right? There's no liquids up there. You don't need to worry about that. It just, any liquid or gas inside of the engines just turns to solid, right? And it goes out the engine, and you're good to go. The turbine machinery on the shuttle engines did have a purge on them, if I'm remembering right. But if you fire a shuttle engine down here, like when they did the SLS green run, they had to, right after the test, they had to go back to the core stage and they had to dry the engines out. They basically put a dehumidifier. They attached a dehumidifier at the top and the bottom of the shuttle engine and just dried the engine out. That's the way that they do it with those things, if I'm remembering right. The gas purge, though, on the Merlin engines is huge. That makes it so that the thing doesn't rust from the inside out. That's part of the reason why you can reuse them. When is the tower going to be ready? I'd say we're probably like 80 to 90% complete here, Popsicle. How fast does it rust? put salt on some metal and come back the next day. About that fast. Thanks again for taking the time to answer. No problem, dude. Speaking of, I actually learned the exact reason why your phone gets hot when you're using too much data. It basically comes down to signal noise reduction. Very interesting. Oh, that's cool. Right on. Signal noise reduction. Okay. Oh, pouring more concrete. So this is a pumper truck. They're moving the arm into position. See, the arm has a little white pipe on the side. They pump concrete up through that thing. There's no cement mixer, though. There's no cement mixer, though. They're moving it into position. You should see a cement mixer come up next to this thing and start pouring concrete in the pumper truck. The cement mixer pours it into a reservoir. That reservoir is an auger, and it pushes the concrete up and over so they can reach in and pour concrete whenever. It allows you to pour concrete faster. Concrete pumper truck. Concrete pumper truck. Sorry, I just like saying pumper truck. I'm not going to lie. So SpaceX is pouring a new foundation over there. There's more methane pipes. Pumper dumper. Now, I didn't say that, Cerebro. Those are your words, not mine. And now it's time to point out that this structure that SpaceX is building is frigging gigantic. Here's your scale moment of the day. Look at the dude sitting up on the scaffolding up there. Yeah, this thing is not small. Holy crap. That thing's freaking huge, dude. Trivia night, cement and concrete are the same thing, true or false? Nope, different. One is wet and the other one is dry. Concrete is the hard stuff, cement is the wet stuff. Huh, wet stuff. Boom. Ba-da-da-da. 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 Do-do-do-do-do-do. Bow. Ba-da-da-da. Ba-da-da-da. I'm thinking up the lyrics. With a purposeful grimace and a terrible smile, he pulls the sitting starship up high now. Quick disconnect, rotate it into position to launch, put the fuel into the rocket. He picks up the rocket and he puts it back down on the super heavy, weighted to something that rhymes with down. Oh no. This rocket's got to go. Go, go, Mechzilla. That was bad. That was bad. That was bad. I'm just gonna pretend that we didn't do that. Ground? Well, we don't want it to hit the ground. Not at least until later. Don't quit your day job. Yeah, see, it's always funny when people say that because my day job's entertainment. Or cringe. Cringe is entertainment to some. Boom. Roasted. That was bad and you should feel bad. Clip it so he never forgets, huh? Don't worry. I don't need a clip to remind me that I am cringe. But see, that's the thing. You have to embrace the cringe. You guys welding something up there. Tig. What is this? What is he doing up there? Oh. That looks like a TIG welder. Huh. Yeah, maybe, Alex. Maybe a little bit. No, that is so not right. Yep. Yeah, you probably want to make sure you're harnessed up there. What is this thing? I don't know, man. Maybe the pad isn't 90% done. Maybe it's like, I don't know, 70% done? Yeah, see, look, there are guys that are... This is a window cleaning rig right here. These guys are going up and down the window cleaning rig and sanding down the tracks that the chopsticks run up on. SpaceX must have figured something out from lifting the load simulators up and down. They must have figured that painting the rails is no good. The tolerances don't work. Because ever since those load tests where they pulled the balls up in the air, they sent out guys to sand down the rails. They're sanding them down to bare metal. How do they run electric up there for those welders? A generator or something? They just lift a generator up there, Sawyer. Yeah. EJ will face his cringe. He will permit it to pass over him and through him. And when it has gone past, he will turn the inner eye to see its path. Where the cringe is gone and there would be nothing. Only EJ will remain. I must not fear. Fear is a mind killer. Yeah. The test. Icular demo. Yeah, for the reals, it was a test particular demo because they were particularly testing the mass, so we'll call it a testicular demo. Yeah. There's the payload bay door thingamajigger. See the payload bay door right there? I'm not sure what they're doing with that thing. Test article. Mm-hmm. Yeah, Alex. Yeah. Burbs. Here, look at these burbs instead. I thought this cat was supposed to be smart and mature. Cats are smart and mature. Serious? Oh, you made a typo. Yeah. Well, you made a typo. You've automatically lost. What did you lose? I don't know, but you made a typo, so you lost. You can see the gantry crane up there in the high bay. I love how the high bay wasn't even finished and they were like, we need a higher bay. Oh, that looks like a little bit of a pavilion there to watch rockets launch from. I hate you. Doesn't matter. It doesn't matter if you hate me. You made a typo. I win. You lost. Get used to the idea, son. What did I win? Don't know. They're going to launch Starlink 2s before they have entry and landing figured out. Savage. Our high bay needs a higher bay. There's the freaking header tank thingamajigger. I'm telling you, that's a common bulkhead header tank right there. That's what we're looking at. They doubled up the header tanks at the front of Starship. There's a methane and a LOX tank up next to each other. That is a CBH header tank, which is cool. I agree. Twitching. Why does the common bulkhead have giant holes in it? For the downcomer, Cerebral? Because the common bulkhead for Starship has a pipe that goes through it. The methane tank, the pipe to the bottom, because you need the fuel down there, and the fuel is up high, and there's an oxygen tank in the way. There's what's called a downcomer, so there's a pipe at the bottom of the tank, and the liquid methane goes through the liquid oxygen tank down to the rockets. Yeah, that's why there's a hole in the center. See it up there on the left? Too small? I don't know, Vasya. I mean, it depends. I think that looks right. It looks like the right header tank to me. That's a jig for making bulkheads that they're moving around, by the way. Staircase section lowered into the wide bay. Okay. Oh! Okay. Huh. No, hey, come back. Bro, do you even lift? Vasya, let's look at that one more time. I want to see that damn tank. That thing. It looks right. It looks like the right size to me. Is this staircase the same as we saw mass produce a while ago? Yeah, that's the exact staircase, Ilforce. The one there they were building outside? Yeah, that's one of them. Guys, I think that's a common bulkhead header tank. What's SE? Who likes SE in his spare time? Wait, what are you talking about? Spaceflight engineering? Oh, software engineering. Oh, systems engineering. Yeah, no, I like systems engineering. That's fun. Interesting, Dama. Well, yeah, I hope everybody's okay. Yeah, I mean, systems engineering or software, dude. One of these days I'll crack into it. And the thing about software engineering is that I know I'm going to crack into it and I know I'm going to like it. That's why I'm like, oh dear. I know I'm going to enjoy it. Shuttle code review when? Oh, God. You know, some of us in chat will cringe as you're learning, but others will want to help. Hopefully, I'm gonna quit my job, so soon I'll have plenty of time to teach if you want. What? Wait. Alright. Okay. Code is literally life. Football is life, coach. Yeah, like, I'm afraid to jump into software, because if I jump into software, I know I'm going to enjoy it. You have the same type of freedom with your engineering that you do as aerospace engineering. There are 1,000 different ways to make a plane. There are 1,000 different ways to make a piece of code. The key is to find the way that does it the best and the easiest. And I mean, it's all application, just like everything else, but yeah, I know software will scratch that itch. What language? I don't know. I took a Java class in high school. That was 15 years ago. What year is it? That would have been 2004? 2004? 2005? 2000, somewhere around there. I could see you making an entire car mechanics mod for Project Zomboid. C# is a really nice language right now. Right on, Gunny. I messed with C++ when I modded stuff for Tribes, Beasel, way back in the day. Like, way back in the day. I know a little bit of Python. We learned a little bit at school. Just a little bit, though. I probably disregarded most of it. I'm starting to do stuff in Stationeer's MIPS code, a real game changer. +1 on C#. I wish I could use it for my job. I'm really nervous about the whole storing methane at the orbital tank farm situation. Like, when are they planning to get permission to store methane? Liam, you know that they abandoned the methane tanks that they put in and just installed ones that are to spec, right? They just put more methane tanks on it. If you learn Python 2, which of it at school did you like? If it was at school, you likely did. A number of things have changed in Python 3, but it's not bad. Yeah, Weather Guide. This was when Python was just coming around. Well, not when it was just coming around. When did I learn Python? 2007. Frick, that was a long time ago. 2007. I remember like it was the new hotness because there was the newest version of Maya, which was like Maya 7 or Maya 8, had Python. You could implement Python into it, and everybody was like, oh my god, you gotta learn Python. You gotta learn Python. Python was released in 1991. Yeah, so no, it was like everyone was like, "Oh, you got to learn it because they had it for Maya. Like you could code stuff in Maya in Python or something like that." I don't really remember. Future was yesterday, old man. Oh, I saved 11 Rust too. Java really using it. Yeah, I know Java's on its way out, Ryan. Okay. Python's pretty good to start learning, but switching to different languages can be a bit of a hiccup if other languages have strict typesets they gave. Python figures out. Type C requires explicit types of variables mostly. Yep. I wish I did computing. It's near impossible to find a job with only an A level in IT. You should poll how many of your viewers are software engineers. There's a good amount of them. Get rolled. Look at this conversation. I mentioned software and a bunch of people were like, huh? Huh? What? Hey, you should learn this. You should learn Python. You should learn Python. You should learn C#. There's a bunch of software people in here. I know. I can see you. Nervous glances. Yeah, I think if I ever did want to learn it, Get Rolled, I think would be okay. I think there's enough talent in here that I could absorb most of it, you know? My whole career has been Python, which is funny because my whole university study was microcontrollers in C. Oops. We all heard them start typing. Yeah, you'd heard the... Ooh, he's talking about this. Ooh. You know? Coding by chat osmosis. I will absorb enough. It's like with Russian. There's a couple of Russian viewers, and I've been able to pick up a lot of it, and I've been slowly absorbing it over time. Russian osmosis. As a lurker, I feel called out. Sorry, Minimum. Joy, нет. Deaf? No. Shh. Why would you bring that up? Don't bring that up in here, man. Shut the frick up, dude. Stop it. Russian osmosis sounds like an excuse for drinking too much vodka. I mean, you gotta, if you want to learn it, you gotta get into the mindset somehow, right? Like, at this point, maybe getting Rosetta Stone Unlimited would be a good idea. Нет. Это не хорошо. Нет. You missed your chance of choosing how much I should donate last time. How much? You're not going to donate anything, Eagle. Let's be real. You just want attention. You're not tipping shit to the stream. Don't kid yourself. Go do this in somebody else's stream, please. Come on. Be real, son. Be real, son. Oh, thanks, Franco. Oh, boy. All right. Well, it's 8 o'clock, guys. And it should be time
Go at throttle up.
round about. The words will make you out and out. Thanks, man. Thanks for the 5 subs. I appreciate it. Seems like a good idea. It's 7 p.m. Central. All right. Thank you. Got about an hour till racing. Damn. I could finish the Hearts of Iron playthrough, but I know if I play Hearts of Iron right now, I'm going to have difficulty putting it down.